Okay, class, this is the continuation of our discussion for Module 3, Lesson 1 for electricity. So, let's proceed now to the analysis of electrical circuit using the famous Kirchhoff's law. So, for Kirchhoff's law, na siya duha ka laws. Ang first one is the law of the currents, the law of current. Ikaduha kay law of kanang voltage. So let's say if we are given a circuit, actually kani siya nga analysis apply gini siya especially sa mga circuit nga combination na gali, di ba? Sa previous nga video is ang atong gi-analyze nga to is series only, and also for parallel and parallel only, wala siya gi-combine. But in a real world, of course, ang electrical circuit is combination na sa either series or parallel. So nindot ni siya nga kaning law mo analyze aning mga ingani nga mga complicated nga mga circuits. So for law of current, actually gi-state niya by Kirchhoff's law. It states that um, the current entering the node is equal to the current exiting the node. So sabot pasabot ani sir. So for our let's say if we have an electrical circuit, so let's say this is our power source, then nay branch dira, nay resistor, then nana po yung other branch ari ana split na pud siya, then miusa diri. Okay, so for this law, actually ang kaning law nag-focus ni siya sa every node. So ang node kani siya, this kani ang gincirclean, this is sample of a node. Let's say node 1, you can also have this is node 2, you can have this node, meaning kanang node dira nag-intersect ang, let's say ato ang connecting wires, especially this one, we can also term this as a node kani siya didapit. Okay, so assuming, let's focus on node 1, and in that node na ay current nga may pass. Let's say from the voltage source na may current nga may pass initially I1. Then this I1, since may enter siya ani nga node, since na ay branches, so may divert ang some parts of current I1 may divert ngadto, and then we're going to denote this as I2, and others may divert pa daw ngadto sa babaw, and then we're going to call this one as I3. According to this law, it states that the current entering the node, so ato ni siya enlarge, it will now look like this. Muna itong node ana siya, then may ubos. Okay, so unsa may current nga misud, that is I1, diba? I1, then this one is I3, this one is I2. So we can say by the law of current that is I1 is equal to I2 plus I3, because I1 is the current that enters, and both I2 and I3 are the currents that exits this node 1 here. So mara siya, and then this analogy is the same with the water pipe. In our water pipe, diba, in our water pipe, let's say if we have here a pipe, then naatay branches ari, naatay fittings, so nay fittings ari nagana, so naatay fittings, so may gawas na pud ngadto, so if we have a pipe that enters in this fitting, so our fitting is the same with our node in our electrical circuit. So if we have flow rate here Q1, pag agi sa node may split, so may ito siya Q2, and then the others is Q3. Of course, law of conservation of mass, we can say that the current at flow at Q1 is just equal to the current flow at 2 plus current at 3. So the same thing with the law of current. That is, the current entering the node is just equal to the current exiting the node. So mara gini atong hinumduman class kani siya. So this can be applied for all nodes depending upon the choice of your analysis. So let's proceed to the kanang kuan, Kirchhoff's law of voltage. So manay kaduha, the law of voltage. Law of voltage. So the law of voltage states that the sum of the voltage in a loop is 0. Okay? Muna siya ang law of voltage. So, unsay both pasabot niya ni. So, again, if we have a circuit, so, nani, ana, then, napoy ikaduha diri, ngana, then, another pod area. So, again, these are series of resistors. So, here, if I'm going to label this one, so, kung mag-label ta, let's say this is A, ako gilabel ang mga nodes sa C, D. So, ang pag-label na ko sa nodes E, F, then G. This one is H. So, giuman diri nga the law of voltage states nga ang sum daw of the voltage in a loop is 0. So, unsa may mga loop nga ma-produce nato out from this circuit. So, we have a lot of loops here. You can have loop 1, that is loop ABGH. So loop ABGH, so naka-enclose na siya. You can have the second loop. You can have BGFC. So BGFC. You can have CFED. So CFED or DEFC. Kaupat, you can have AHFC. You can have AHFC. Kalima, you can have AHDE. So AHDE. You can also have BGDE. BGDE. So unom kabuok. Okay, unom kabuok ang imuhang loop nga ma-produce. So within this loop, ang sum sa ilang voltages is equals to 0. So let's try analyzing loop 1. So sa loop 1 class, okay, considering this one, A, then B, then G, then H. Here, ang given nga mga kuan is we have a power source, okay, then we have a single resistor. Yan na siya. So here, sign convention ta, if this is positive terminal negative, so assume na to that the current flows from positive to negative. So current flows from positive to negative. So let's say this is I. Okay. Again, in applying this second law of voltage, be sure to remember this one. Magini ato i-remember. Now, if we have a resistor, in order to solve for its voltage, okay, if this is the positive side and the negative side, and then if the current flows in that way, okay, the voltage, assuming this is R, this is I, the voltage here that is being generated is equal to negative of IR. Negative IR. Okay? Nga naman, ang ipasabot ani magod kay the change in voltage. The change in voltage. Why negative? Because kung ato i-analyze sa fluids, di ba ang positive side ato siya gitinod nga higher potential, where in fact of course we all know nga ang concentration sa electrons kaysa negative. Since akong pasabot ganiha sa previous nga sign convention, ato lang gi-assume nga higher potential si positive, that is positive whatever volts, let's say positive 5 volts. So si positive 5 volts miagi ni current ay miagi ni resistor of course consumes energy ingadto siya sa lower potential. So the change, di ba, the change in voltage is final voltage minus initial. So si final voltage kay mas gamay ni initial, so automatic the change there is negative. That's why we have V equals negative IR, meaning the voltage that will be generated for every resistor, assuming with this direction, if the current has this direction, that is negative. However, if we do the opposite, let's say this is our resistor. Again, this is the positive terminal of our voltage source, negative terminal R. Now, if the sign convention of our current is in the opposite direction, so unsa naman mahitabaan ni? So we have at the lower potential towards the higher. So the change here in voltage is already positive. So therefore, our voltage now is equals to positive IR, not negative IR, because the change here is from lower potential to higher, meaning pasaka ang voltage, unlike here paubos ang voltage. So diba, the change in voltage delta V is equal to the final minus initial. Mara take note, sign convention. So here in our example for loop ABHG, we can say that the voltage here, let's say this is the source voltage Vs. Of course, that is Vs plus, ingon man ta, the sum daw. The sum of the voltage in a loop is 0. So, nanapot ay voltage dito sa R. Let's say this is R. So, since ang direction dito kay pangadto, and we all know that kaning one leg of our resistor is naasa sa positive terminal, this is in the negative terminal. So, therefore, kung sa'yo nahitabo sa itong voltage dito, may drop. Kaya diba, from higher potential to low. And then, since this is the direction of our current, so that would be negative. That is negative. The current I multiplied by the resistance of that resistor is equal to 0. Or in short, simplifying, that would be Vs minus IR is equals to 0. So that is negative. Why? Because again, diba, ang direction sa current is pangadto, then the voltage drops, and drop man ang voltage drop from higher to lower. Therefore, the change in voltage there is negative. Wanang negative po siya ari. Now you can also solve for the other loops. Unon mi kabuok, so kamo na bahala. Or let me have B, C, G, F, GF for the last, as a last example. So let's say, can you see B, C, then since naman dire, then kanay pod ubos. So G and F. Let's say I have here a current. This is R1, R2, R3, then R4. So nakoy I1, then napokoy I2, napokoy I3, so muna iyang sign I4. So here, assuming this is connected with the positive terminal, disconnected in the negative terminal. So considering the first resistor, so automatic kani iyang one leg diri is connected sa negative, so voltage drop dira. So we have your negative I1 R1, then here I2, this is the positive terminal, negative voltage drop pagyapon, minus I2 R2, Diri ni I3 padong siya ngadto, this is the negative terminal, this is the positive. So since ang direction kay padong ngadto, so negative gihapon ni siya. Minus I3 R3. Here si I4, the direction there is padong ngadto, that is from negative to positive. So bali na siya, unlike the others that is from positive to negative. So therefore, we now have plus I4 R4 is equals to 0. So nga na siya class. If voltage drop, negative. If pasaka ang voltage, positive. So muna siyang we have subtraction here and addition. So nga na siya class para di maglibog. Duha ra ka buok inyong tigaman sa Kirchhoff's law. The first one is the law of current. The second one is the law of voltage. Meaning the sum of the voltages in a loop is 0. Okay, para ma-realize ni, so let's have some problems. So problem 1, we have find the currents in the circuit shown in figure 18.5 by using Kirchhoff's rules. So here ato you find ang how many currents. So we have required is I1, I2, and I3. So we have 3 unknowns. Actually, para mas madali ta, di ba in mathematics, sa inyohang topic is nakabot mo ani or nakatakod mo ani kaning topic for 3 equations and 3 unknowns, simultaneous linear equations. Di ba? In order to solve for these 3 unknowns, we need to have at least 3 equations pod. Okay, we need to have at least 3 equations. So we're going to find these 3 equations para masolve na to si I1, I2, and I3 simultaneously. So solution. So here medyo libog jud gani siya, daghan kay makuan given. Now let's focus on the node muna. So let's apply first the first law of Kirchhoff's katong the law of current. So if I'm going to apply here B, in the node B, wala mo lang interaction. I need to find some node nga na ay relation ang tulo ka buok, I1, I2, and I3. I cannot do for B because si I3 wala mi pass through diri, even A wala pod. For D, although may pass through diri si I3, diba si I3 may pass through diri and also si I2, but si I1 wala po diri. Okay? So, or maybe naa si I1 dira, I don't know. Pero ang pinaka-obvious diri ug mas straightforward is for node C. So, let's start with law of current at node C. Okay? Again, dili ko ni B kay walay interaction ang tulo ka parameters nga atong gipangita. Ni A dili pod, ni D not explicitly nga gidefine. So C lang kay tungod sa C, kuto na i-zoom in, miagi man si I1 dira, miagi si I1, then mi split up padung ni I2 ni I3. So therefore we can say that the current entering node C is I1 is equivalent to the current that exists so that is I2 plus I3, or transforming this into a general equation, so it will now become I1 minus I2 minus I3 is equal to 0. This would serve as my equation 1. So natin sa equation, we only have 2 equations ang kailangan. So gamit natin ato ang loop kay wala man tayo laing node nga makarelate nila. So we're using now the second law, the law of voltage, that is in either of these kanang 3 nga mga loops. So I will choose loop. Okay, akong choose ko sa una nako is I'm going to choose loop kaning naa sa sulod, kaning blue, yung loop B, C, D, A. So loop BCDA. Again, ato na i-extract, mahimo siya og ingani nga figure. So, ingani ang loop BCDA. Dira, then miagi miana. Okay, this is positive, negative. This is 6 volts. This is C, D. This is A and B. So here, natay resistor nga 4 ohms. This one is 9 ohms. And then here, miagi ni 4 ohms si I1. Miagi ni 9 ohms si I3. Okay, so nanata. Now, let's start with the 6 volts. So, ang flow sa current is pangadto, so that is from positive to negative. Okay, so therefore we have here the voltage at the source plus. So since kani nga terminal, kani nga leg dire, this leg here is the positive terminal and negative, so meaning if ang direction of the current is from positive to negative, we have voltage drop. So negative dira. Okay, so that's why we have minus I1, then R here, that is 4 ohms. The same thing with the 9 ohm resistor. Since this is the positive terminal, the negative terminal here, so and the direction of the current is from positive to negative, so naka voltage drop ta dire, so we have a negative volts there. And always don't forget the formula, Ohm's law for voltage, that is current times resistance. So minus I3, R there is 9, is equal, o na may laing giagian, o na may any resistor or any other batteries, so 0. Okay, so here kuan ato siya i-equate in terms of ato i-isolate ang unknown sa left side only, and then the constant on the right side. So this can be rewritten, pwede po nato i-transfer ng duha, bilin na si voltage source. So we have 4I1 plus, I can also add 0I2, kaya man I2, then plus 9I3 is equal to the voltage source of 6 volts. So this would serve as my equation 2. So we only have one more remaining equation para masolve na to ning tulo ka current. So ang last nga loop is kanang iyang gi-indicate dira. So the last loop there is a loop CD. So kanang loop CD. So in loop CD, mo ni ang drawing. So may ana dira, then may balik, then may ara. So this is C, this is C, this is D. So here ang miagi dire, okay, assuming nga atong flow sa atong current is kuan, assuming kanang positive if kuan, or kanang pwede pa na pa-clockwise tong reading. So here ang resistance above is, this one is 5 ohms, below is 9 ohms. Here the direction of the current for 5 ohms is pangadto, this is I2, and for 9 ohms pangadto pod, that is I3. Okay nga to siya. So applying the Kirchhoff's law for voltage, so here so good ta ni 5 ohm, since this is the positive terminal this is the negative, so nag-start ang ihang direction from the positive to negative, so naka voltage drop, so that is negative. So what upod nato, that is negative 5 ohms times I2. Then here, okay, here since loop ni ha, so dapat if nag-una ta dira og calculate, okay, if nag-una ta nga si current pa daw nga to, automatic mga ta kung makaloop ta. So here from this loop, since this is positive and this is negative, so against siya sa direction sa atong loop, kaya ang loop na to kay pangadtuman niya against siya sa direction sa atong kanang current nga I3. So therefore kani atong sundon kaning from negative to positive, so we have a voltage voltage spike, or may increase atong voltage. So therefore ang ato dira is that would be kuan na siya kanang summation, or I mean kanang addition na siya. Okay, from negative to positive, that would be plus 9 I3 is equal to 0. Kaya may lain. Again, plus siya kay sundon mo na to. Okay, sundon na tong from positive to negative, automatic negative siya. However, opposite man ang direction sa loop, mo na positive pud siya. Okay, if sundon na to ang loop, that is from negative to positive, so ang change sa voltage ra is positive, kay di man na siya voltage drop. Ang voltage drop naman kay from positive to negative. So here, rearranging, so we can say that we have 0 I1 minus 5 I2 plus 9 I3 is equal to 0. So we have 3 equations and 3 unknowns. So ato ilista. The first one is I1 minus I2 minus I3 is equal to 0. The next one is we have 4 I1 plus 0 I2 plus 9 I3 is equal to 6. We have 0 I1 minus 5 I2 plus 9 I3 is equals to 0. So this one actually, in order to solve for the 3 unknowns here, pwede mo na i-plug in mo sa calculator naman tayo solving, or you can use Gaussian elimination or Cramer's rule. It's up to you, but for me, para madali ta, gamit na ako sa calculator. So kanin siya, this is 3 equation, 3 unknown. So here na tadi 3 equation and 3 unknown nga solver. So ato input ang ilang mga coefficient sa every variable. So kanin siya may ni og 0, then 9, then 6, then 0, negative 5, then 9, then 0. So we have I1 is equal to 84 over 101. I2 is equals to 54 over 101. This is ampere. I3 is equals to 30 over 101 ampere. So therefore, these are the currents that can be found in our circuit. And if our current is positive, automatic class nga ang ato ang direction nga i-indicate this ato ang circuit is kanang true. Kay positive man siya. If we have or makasugat mo negative nga answer, then pasabutan na is opposite ang direction nga imong gikuan nila giset nila opposite. Okay, so mana siya. This is how we're going to solve for kanang circuits using Kirchhoff's rule. So mana siya imo sa kuan imo sa pangitaon kung or indicate kung pila ang mga unknowns. So if we have two unknowns, so at least makapangita kag duha ka equations. If that is three unknowns, at least makapangita kag tulo ka equations para makasolve ka. Then applying the first law of current, then the second law, that is law of voltage. Okay, so let's try another one. So we have here, find I1, I2, and I3 in figure. So kan yapon three equations, then three unknowns sa patong pangitaon. So required I1, I2, and I3. So here sa figure, sa figure kay gi-indicate. So solution. First is the law of current, and I'm going to focus on node C. So sa node C ko mag-focus kay dira nag-abot man ang mga currents, that is I1, I2, and I3. So at node C we have I1, the current that enters is equal so the current nga may exit, that is I2. I mean si I1 and I2 mo day may enter sa node C. So that would be I1 plus I2 is equal to I3. Rearranging in a standard form, that is I1 plus I2 minus I3 is equals to 0. So this would be my equation 1. So nanatay usa, at least 3 man ni siya. So kaduha nato, kaduha nga problem, ikaduha nga generation is we're going to use the law of kanang the law of voltage. So here my first loop would be loop EFBC. So in loop EFBC, so natay voltage source, natay usa ka resistor, then nabutay usa ka resistor diri. So here this is our positive terminal, negative. This is a 14.0 volts. So ang atong sign convention ini sa atong pag-analyze sa loop, of course, normally ang current mo travel siya from positive to negative. So here since si I2 kay nagikan diri, diba si I2 kay gikan man diri siya, naapod tay kuan day natay battery nga usa. Plus minus. So this one is 10 volts. Then this one is 6 ohms. This one is 4 ohms. So si kuan diri, kato i-analyze, ang miagi sa itong si I2, si I3, miagi diri, miagi. Okay, miagi po diri si I3. Then pagbalik nga to I3 gihapon ni. And then kung gikan diri si kuan, kung si I1 kay gikan diri, so automatic kani I2 ni pod ni diri. I2. So here ang flow man nato, sign convention nato sa within this loop EFBC is from positive mga tuta ana agi sa wire diri then balik na to. So this is our sign convention. And as you notice, ang atong direction sa current sa 4 ohms kay pa-opposite siya. So diba kabantay mo? Pangadto siya. This is I2. Opposite siya sa atong sign convention. And then this is positive terminal negative. So supposedly in this orientation on that, positive padong negative is voltage drop, but since ang iyang direction sa iyang current is opposite, so magiging positive siya kaya diba voltage drop man ta kung pangadto tas ubos. So this, since ang iyang direction is pababa, pataas, therefore positive na siya. So we can say this one is 4, the voltage here is 4I2 positive. Then next, so sa sunod, sa ato ang direction, kani siyang loop direction, miagi siya og battery, which is from negative to positive. So ipasabot ang negative to positive na ay increase in voltage, right? Kaya di man positive to negative. Again, basta positive to negative terminal, voltage drop na siya. Kung negative to positive, voltage spike or may increase. Therefore, we have plus 10. Then, here na pod sa atong 6 ohm, what is the direction of our current here? Hinglabay man diri si I1. Labay si I1. So, ang ato pong direction sa loop is padong po nga to. So, same sila. So, this would be negative kay from positive to negative kay kani positive terminal, negative terminal. So, from positive to negative terminal, voltage drop. So, we have negative. So, this would be negative 6I1. Wala may line gisugat, mabalik na siya sa 0. Of course, kani siya, since we have negative to positive, so apil pa na si 14 volts nga source sa battery. Atong source, of course, ay kalimti ang source, which is also positive kay voltage rise man ang source. Plus 14 is equals 0. Again, ganang voltage rise ang source kay diba kung atong kitaan sa yung direction sa pag loop is from negative to positive, voltage increase. So here, rearranging the equation and combining the constant on the right side, we have negative 6I1 plus 4I2 plus 0I3, I3, so 0 is equals to transpose 14 and 10, that would be negative 24. So this would be our second equation. So mara siya class. And then next, pangtulo or ikaduha nga loop. Loop B, we're going to consider BCAD. BCAD. So ang drawing niya, yan ni, na battery, na resistor, then na last nga resistor diri. Then wala na. So this would be 6 ohms. 6 ohms. This one is 2 ohms. Then 10 volts nga battery. 10 volts wherein iya terminal is negative and positive. So again, siya ato followon sa atong loop analysis. In our loop analysis, mag-start from positive ang travel sa current. Starts at positive, musugat sa 6, muari, then mubalik adto sa negative. So here, the direction of the current at resistor nga 6 ohms is sabay pud siya sa direction sa loop. Kato, this would be I1. For the 2 ohm resistor, sabay pud siya. This is I3. Okay, so here, maka deduce na ta. So, atong source voltage, negative to positive, sa looping, that is positive 10. Here, at the 6 ohm resistor, this is positive to negative, so voltage drop, diba? This is positive, then negative, So voltage drop manang minus 6I1. Then here, this is positive and negative. Okay? So voltage drop na pod. So we have minus 2I3. Makibot ang voltage drop because the direction of the current also here is kanang along or ni follow siya sa direction sa loop. So this would be equal to 0. Rearranging in order to produce the third equation and the last, negative 6I1 plus 0I2 gi 0 kay wa man minus 2I3 is equals to kaning 10 transpose on the other side, we have negative 10. This would be equation 3. Now rewriting the three equations, so we have here I1 plus I2 minus I3 equals 0. The next negative 6I1 plus 4I2 plus 0I3 is equals to negative 24. And the last one is we have negative 6I1 plus 0I2 minus 2I3 is equal to negative 10. Now solving this, you can use either methods, mathematics. So we have 1, 1, negative 1, 0. We have negative 6. We have 4, we have 0, then negative 24. Then we have negative 6. We have 0, we have negative 2, and we have negative 10. So our I1 is equal to 2 amperes. I2 here is equal to negative 3 amperes. Our last current is negative 1 ampere. So now we have negative. Pasabot ang negative, meaning the direction of our I2, instead of pasod siya, the actual is pababaw kay negative man. And then for I3, ang atong na-assume is paubos, where in fact pangato day siya. Okay, paana day siya, class. Basically, ingon ana ra, class, if we met some negative answer for our current, mabali lang ang iyahang sign. So ingon ana ra siya, class. Good day, class. So this is a continuation of our discussion for module 3 lesson 1, all about electricity. So continuation is here, and since we are already through with answering with this problem using Kirchhoff's law, so let's proceed to the third example. This example, we're going to use the Maxwell method. So ang akong first method nga gi-introduce sa inyo is by using Kirchhoff's law. Here we're going to use the Maxwell method. Now for Maxwell method, this one is a little bit simple, and then ma-reduce niya ang number of unknown variables, because as you can see right here, in this example, the currents, the number of currents are not specified. In our previous nga example, gi-specified na niya tong tulo ka currents, but if you really want to reduce the number of currents here, so it will take a lot of time. But ang pinaka basic ani is you assume nga si 10 ohm, like let's say for example this 10 ohm na siya iyang kaugalingong current, si 10 ohm pod sa ikaduha na iyang kaugalingon, and so on and so forth. This 5 ohm, 5 ohm, and this last 20 ohm. So if we have 1, 2, 3, 4, 5, if we have 5 current, then it would be very very hard for you to gather 5 equations. And of course that 5 currents, unknown currents, will be of course reduced to a very small number of currents if you know how to analyze. But in this case class, I will going to introduce you Maxwell method, because this method will um, shorten the time to solve for this kind of problem. But before answering this, I'm going to introduce you what this method all about. So for this method, suppose, okay, we just ignore the problems. Suppose we have here an electrical circuit, power source, and then I have here some resistor and another resistor, then next another resistor, then resistor, and then last one another resistor, then another resistor, then another resistor, and that's it. So here, even if you don't specify the nodes, you just have this figure, and then you have a source of voltage here. We're going to denote this as E for EMF, and this one, just don't forget to indicate the sign of the terminals. This one is positive, this one negative, and the next, of course, I will going to put here some labels for our resistance, or for our resistors. This is for R1, R2, this one R3, this one is R4, here R5, R6, and R7. So in Maxwell's method class, actually is here we're going to assume, okay, we're going to assume a direction of the current for each loop, okay, and then your loop, it depends upon you. Just choose the loop that is very obvious or very visible, nga klaro kaayo nga makita dayon. Diba? Here, ang obvious yung maklaro na to, how many loops are there. So we can generate 3 loops here, because diba naman tayo 2 Lucas squared. This one, and also this one, the last one, this one. Tulo ka buok. And then you can create your own direction of your current flow. But for me, I will follow the sign of the terminals. So here, this from positive flowing towards negative, and I'm going to label this one as this is my first current. This is I1. Okay, so meaning I1 passes through our power source, and also for both resistors R1 and R2. So yung agi siya. The next, since what I have told you by Maxwell's method, assume a direction of current for each loop. So since obviously natay tulo ka loops, so assume po na here my direction is, or my direction goes like this, and I'm going to label this one as I2. Again, take note, be mindful to the current that passes through each resistor. Let's say here for R3, only I2 may pass. However, for R1, there are already there are now 2 currents, di ba? Kay si I1 is also passing there, and also I2, but of opposite direction. So be mindful with that one. And then the last loop here, and I'm going to assume nga ingana po ang direction sa iyang current, and I'm going to label this one as I3. Class, actually it's up to you. You can have this direction paana, so it's up to you. Anyways, ang ato raman na siya ma-verify na imuhang assume by looking at the sign of our final answers. Okay, so unsa ang pag-work sa Maxwell? So in this example, we can create three unknowns here, di ba? Three variables. So sabi mga unknowns, we have here I1, I2, and I3. And it's also perfect because with these 3 unknowns, of course, obviously we can derive 3 equations because we have 3 loops here. So let's start with the first one. So again, first loop. So since may agi siya, mihagi siya ni R1, so there is a voltage drop, so we're going to label that one as negative R1 I1. However, for R1 there's also an opposite an opposite current, which is I2. Diba si I2 may pass through po ni R1, so therefore we're going to add that one because the direction of I2 with respect to I1 is opposite, so therefore that would be plus R1 I2. Okay, after R1, si direction sa I1 may sugat niya ni R2. Si R2, only I1 passes it and nothing more. Kay si I2, nga naman second loop. So, I2 does not affect R2. So, therefore, only I1 ang may interact sa iya. So, therefore, since this side here is positive and negative, so therefore, we have voltage drop. So, for voltage drop at R2, that is negative. So, negative R2 I1. Next, return siya back to our power source. Of course, our power source, that is increase in voltage, because as you can see on the direction, that is negative to positive, so that is increase in voltage, that is plus E equal 0. So naanatay kanang first nga kuan, we already have our first equation, and combining, we have for I1 that is negative R1 minus R2, and then plus R1 I2 plus 0 I3, o matay I3 sa tubatag 0 plus 0 I3 transposing E kay constant siya, that is negative E. So that is the equation being generated for first loop. Now let's go with the second loop. So for our second loop, so I2 na. So for I2, this is our direction for our loop 2. Kaning ato ni sundon si I2. Now, I2, let's start with the resistor number 3. For R3, only I2 maoy ni interact. So here, this is positive, negative. So therefore, there is a voltage drop. So we have negative R3 I2. Next, proceed ni R4. So si R4, this is the positive terminal, negative. So therefore, voltage drop again for I2. However, for resistor number 4, there are two. Okay, there are two currents na nag-interact sa iya. The first one is I2. The second one is I3. But I3, opposite direction sa ato ang I2. Okay? So, for I2, that is voltage drop. So, may mo siyang minus R4 I2. However, the direction of I3 tells us that there is a voltage increase. That's why we have plus R4 I3. Again, si R4, duha ka buok current nga nag-interact niya ha. So, not only I2 but also I3. So, I think diri wala may resistor, then proceed ta ni R1. So, for R1, again, duha na po yung interact niya ha. That is I1 and I2. So, for R1, let's start with I2. So, since this is the negative terminal, this is the positive terminal, so we have voltage increase. Again ha, sunday gid kung asa mga positive and negative terminal. So, we have a voltage increase, okay, from negative to positive. So, we have plus R1 I2. However, for I1, since I1 is from positive to negative, opposite direction man siya with respect to I2, so therefore, this would be negative voltage drop. So, minus R1 I1, and since wala naman lain, so that would be equal to 0. So, here, rearranging, so we have negative R1 I1, then plus for I2, that would be R1 minus R3 minus R4, then I2, then for I3, that is plus R4 I3 is equal to 0. This would be our second equation. And we only need uh, one equation in order to complete this, because we have three unknown variables, then at least we have three equations. So ngadto ta sa third loop. For the third loop, the last loop, so ang akong sign convention na gigamit is this one. Rotating siya clockwise. So let's start with R7. R7, siya lang interact. Okay? Si R7, the current that interacts for the resistor number 7 is only I3. So therefore, put there, since this is positive and negative, so we have voltage drop. So that would be negative R7 I3. Next, for R6, since the R6 wala na ilang interact, only I3, so and then this is positive and negative terminal, we have voltage drop again, so that would be negative R6 I3. Next, for R5, still I3 gihapon, wala na ilain, and then since this is the positive terminal and negative, so therefore that would be voltage drop, so that is minus R5 I3. Next, for R4, there is a two interaction, that is the current I3 and I2. So for I3, since this is already a negative terminal, then this is positive, so negative to positive magiging increase in voltage na, so therefore we have a positive here, so that is plus R4 then I3. However, for I2, since the direction is opposite, so voltage drop, so we have negative R4 then I2. What else? So may balik naman ta, so that would be equal to 0. Okay, again, Kirchhoff's law of voltage. So here, rearranging this, so we don't have I1, so we just put 0 I1 plus R2 here is minus, so that is minus R4 I2. For I3 daghan kayo, that would be plus R4 minus R5 minus R6 minus R7, then I3 is equal to 0. So here we already have three equations and three unknowns. So first equation, second, and third. So therefore, we can now solve our circuit. And here, if we are using Kirchhoff's rule, so daghan tag ma-involve nga current. Let's say mag-assume pa ka if ever wala gi-indicate ha. Kay most of the problems sometimes di na lang indicate, so therefore mag-assume pa ka dira nga daghan kay kag current, meaning imong gi-assume current kay nagdepend pud sa kadaghanon sa resistor. So if we have here 7 resistor, then kung di ka kay ba analyze, so ang iyo pong ma-assume kay 7 pod nga mga currents and unknown pa gid sila, so daghan kaayo kag problemahon. So in order to reduce that, mas safer kung mag-use ta ni kaning Maxwell nga method. So muna siya ang Maxwell nga method, and we're going to apply this in our sample problem here. Okay, so ato ni erase, focus ta sa ato sa given problem. So here what we are to find is the potential difference between points A and B. So the voltage here, A and B. Actually, the voltage of A and B, that is just equal to, okay, put here required. For letters A, that is the potential difference between A and B. Actually, class, that is just equal to the voltage of the resistor with 10 ohm nga resistance. Kani siya, equal lagi na siya. Okay, so kay bawo tayo sa formula na, that is just equal to unsay current nga milabay dira, that is I at 10 ohms, and then of course the resistance niya. Okay, then for letters B, that is the current daw in the 20 ohm resistor. So here, the last one, so that would be I of the 20 ohm resistor. Duha ra tong required 3A. So here, let me draw this circuit again. So ito i-draw para makakitag loop for Maxwell. So this one, this is our 10 ohm. Then napatay last ring resistor, going back to the source. Then for the second one, yan is siya. And then for the third, na, then diri. Okay, so here we have 10 ohms. This one is 10 gihapon, this one is 5, this one is 5, and this one is 20. Here we have our positive terminal, negative terminal. This is 25 volts. So again, as what I have told you, by Maxwell's method, obviously we have 3 loops here, so we have 3 currents. So I'm going to assume the direction of my currents for the first loop by following the direction of the terminals, of the sign of the terminals. So this is positive, so ngadto yun siya ana, and then mabalik. That would be my I1. Next, for the second loop kani sila, so I'm just assuming same ra pud sa I1, so this would be my I2. The third one, this would be my I3. Okay, so here we have 3 unknowns, supposedly 3 unknowns, I1, I2, and I3. So we're going to solve for we're going to look for 3 variables. I mean 3 equations. So let's start for the first one. The first loop to the left. So the first loop to the left, again, let's start with the 10 ohm resistor. Can I see? For the 10 ohm resistor, there are 2 currents that interact. But let's start first with I1. So I1, follow na lang. So since this is the positive and negative terminal, so for I1, we have a voltage drop. So that would be negative 10 ohm times I1. However, for I2, since naka-opposite man siya, so that is from negative to positive, we have a voltage increase. So therefore, that will be plus 10 I2. Next, after the 10 ohm resistor, let's go to the other 10 resistor on the left, closer to the battery. So here, this time, this would be the positive terminal and then negative terminal. So since the direction is from positive to negative, we have voltage drop, and only current I1 interacts this resistor. So therefore, usara. So we have minus 10 I1. Then balik sa battery. So the battery, in the battery we have a voltage increase. So it will be plus 25 is equals to 0. So here, simplifying, so we have for I1 negative 10 plus negative 10, so we have negative 20 I1. For I2 we have plus 10 I2, and then for I3 we don't have, that will be plus 0 I3. And then I'm going to transpose the constant on the right side, that would be negative 25. So this would serve as my first equation. So dali ra, pwede mo maglibog analyze ng mga circuits. Kaduha, the second equation. So we're going to proceed to the second loop. So in the second loop, we only have 2 resistors here, the 5 ohm and the 10 ohm resistor. So let's start with the 5 ohm resistor. For the 5 ohm, this is positive terminal, negative, so we have 2 currents that interacts here, I2 and I3. Let's start with I2. So for I2, this would be voltage drop kay from positive to negative man. That would be negative 5 I2. However, for I3, that is from negative to positive, so voltage increase. So positive siya, so plus 5 I3. And then next, nasa sunod, the 10 ohm resistor. So for 10 ohm, 2 interactions, I2 and I1. So let's start with I2. I2, that is from negative to positive, so that is voltage increase. That will be plus 10 I2. However, for I1, opposite siya, from positive to negative, so voltage drop. that will be minus 10 I1. That is equal to 0. Okay, ano may line? Okay, so rearranging this, we have negative 10 I1. For I2, that is positive 10 I2 minus 5, that would be plus 5 na lang, plus 5 I2, then plus 5 I3 is equals to 0. This would be our equation 2. Okay, so na ta? So, last na lang last na lang a loop. So, for our last loop, the third loop, so we have 3 resistors here. For 5 ohm, 20, and the 5 ohm on the left. So, for 5 ohm on the right, only I3 interacts. So, here, this would be the positive terminal negative, so there is a voltage drop in accordance with the direction of I3. So it will be negative 5 I3. For the 20 ohm, si I3 gihapon nag-interact and still a voltage drop based on the sign of its terminal. So that will be minus 20 I3. Next, last one is ang 5 ohm resistor nga duhay nag-interact sa I3 o sa I2. So let's start with I3. For I3, since this is the sign of the terminal, so from negative to positive, voltage increase. So we have plus 5 I3. Next, for I2, since that is from positive to negative, so we have voltage drop. That would be minus 5 I2 is equal to 0. Rearranging this one, so we have 0 I1. I1. Then next, we have negative 5 I2. Then for I3, tulo ni kabuok. Negative 5 plus 5, 0, minus 20. So negative 20 I3 is equal to 0. So this would be our equation 3. Now, we already have three equations. So that would be, this is what there is. It would be negative 20 I1 plus 10 I2 plus 0 I3 is equal to negative and 25. Next, negative 10 I1 plus 5 I2 plus 5 I3 is equal to 0. And then last one, 0 I1 minus 5 I2 minus 20 I3 is equal to 0. So here you can solve this. Okay, it's your assignment na lang i-solve ninyo kaning 3 equations and 3 unknowns. Actually, lagay pa maaga ni using Kramer's or Gaussian elimination. But during our exam, of course, ayun na i-shortcut during a part. Solve bagay siya using either those equation, method of elimination or substitution or Gaussian or Kramer's. So, i-review na lang. So, I have a calculator para madali ta. So, for my I1, so i-plug in. So, negative 20, 10, 0, then negative 25. We have negative 10, 5, 5, 0. We have 0. We have negative 5, negative 20, 0. So, the first current, we have I1 is equals to negative 3.75 amps. So, when we have a negative when we have a negative kanang current, so meaning opposite tayo ang direction ana sa actual assumption naman to nato. So for I2 that is equal to negative 10. So again, bali di ice. Then for I3 we have 5 halves, that is 2.5. So si I3 ra mo ay sakto ang pag-assume. So for I3 that is 2.5. So we have 2.5 amperes. Okay, so na naman ta, and then ang required man area is 4A, that is BR. that is the voltage across this resistor kani, voltage across niya ni. So unsa may interact na current. So let's have here for letter A, VR at 10 ohm, nasa first loop ni siya. So that would be equal to the current na may act at the 10 ohm resistor times 10 ohms. Okay? So unsa may current nga naa dira. So unsa gyud may interact sa current diri sa atong Maxwell nga pag-interpret kay diri, di ba? That is I1 and I2, di ba? So that is, kung atong sundon si I1, if we're going to take I1 as positive, so that would be the difference between I1 and I2. So that would be absolute of I1 minus I2. Difference niya times the 10 ohm. So here, absolute I1 nato is negative 3.75. So butang negative 3.75 minus I2. I2 here is negative 10. Okay. Then times 10 ohm. So here, pagkuha na to dire, ato lang i-take absolute, that is negative negative 3.75 plus 10, that would be 6.25. Or you can ignore po, or pwede po di sa nimo absolute. Anyways, ang interpretation po sa negative voltage is meaning ana ang sign, meaning di din siya may higher potential. Maybe B is not the higher potential, maybe A, or say A mas lower nya si B din mas higher potential. Okay, so di na sa to i-absolute para to makita. However, if wala ta nag-absolute ni ini, still the answer is positive. So meaning mas higher potential paghapon si B, because the answer here is 6.25. So 6.25 ampere multiplied by 10 ohms. So the result is 62.5. So we have here 62.5 volts. So ang volt diri ay is 62. So dako kayo ang voltage drop dira 62 volts. So sakto ba negative 3.75, then si I2 negative 10. Okay. Okay class, let's continue. So ang atong nakuha diri is kanang greater than sa unsay naa sa batteries, which is not kanang true. So ang kanin siya for the voltage across this node B to A, actually that is equal to the kuan. So as to is what diri, actually the voltage there is equal to the resistance, this 10 ohm resistance, but the current, okay, the current should be I1 only, because maara mo gud siya gikuan ara marag mo rin na calculate dira Okay, so only for I1. Wait lang. Okay class, let's resume no. So ako na I found out ay ang kaganya kay dako to ang voltage. It's because in the second loop, so sa second loop here nakuwangan niya siya, sorry. So in the second loop kani siya, this I2 supposedly this one is 15 because 10. So kani siyang I2 here, nag-start na siya na. So for the second loop, actually this is positive 5. So I2 positive 5 nagka-baylo siya, so kani siya nga sign. This one is positive and this should be negative. So kani siya negative ni siya kay di ba ang I3 in the second loop si I3 mas opposite man siya sa ato ang direction sa atong second loop. So this would be minus, then plus 10 I2, then minus I1. So therefore this one is negative 10 plus 15 is here, so 15. Then this one is negative 5, so this should be negative. So this should be negative 5. Negative 5 na siya. And then here the rest. This one is actually for I3. As you notice in the I3, this one is for I3. Okay, sa I3 di ay kaning I3 as you notice here since naman siya sa I3 kanin siya is di ba 5 then 20. So si I2 here, I2 since along man din siya along, or here we just neglect for Maxwell die, di ba kang Kirchhoff na to for Maxwell, we are going to neglect this one kay for Kirchhoff na ito ma-apply. So I'm sorry kani siya for kuano ni for Kirchhoff's kay kang Kirchhoff mo gud kay dependent siya upon the direction, but for Maxwell gi-ignore na niya maging di na ka madugay dito. So again, in order to kanang analyze this one again, so pwede tayo maglibog ingan ka Maxwell. So ito na siya erase. Again, ang ganito mga voltage drop is kang kuha nato siya sa Kirchhoff na ito ma-apply. So ito na siya erase kani. But still katong ganiha katong mag-assume ka og direction sa current still part sa kay Maxwell. Kadto na lang mga sign sa iyang terminals mo lang to i-ignore. So again, for Maxwell mo mas sign ni siya is that assume ka for every loop, let's say this is my I1, this is the direction of my current for loop 2, then this is the direction for my current at loop 3. Again, here sa Maxwell, we are going to neglect the those signs nga may kuan nyo ganiha. At i-neglect for the resistor. Unless if na mga batteries, except for battery ha, so i-neglect na to for the load. Okay, i-neglect na to itong mga positive and negative terminal except for the batteries. If na mga power source, ato i-take note ang iyahang sign convention. Okay, so let's start again. So here for our first loop, ang kang Maxwell lang is, let's start with this one, this 10 ohm resistor. So for 10 ohm resistor, we take the positive voltage for I1 kaya yung direction ni I1 positive na siya, so that is 10 I1. However, duha may nag-interact ni 10 ohm resistor si I2 pod, so since opposite iyang direction with respect to I1, so we're going to take that one as negative, so negative 10 I2. Then next, for this one, for this remaining kani siyang 10 ohm pod, so since okay naman siya, wala interaction, so in pass through the si I1, so therefore still positive, that positive yaw siya 10 I1. The next, niagi siya og battery. As you can see, pag agi niya og battery, ang atong convention is from diri na is from negative to positive, di ba? Ang direction kay padung ngadto pababaw na, di ba? So from negative to positive na. So here, if atong flow or ato kanon nga if the flow is from kuan, I mean this is not negative to positive because let's nag-start man ta sa positive terminal to negative terminal, so therefore kana siya is if kanang kuan, I mean negative to positive, so kanang kuan na siya increase ang voltage but of the other side. So here ato diri is the 25. So ang diri atong sign convention kay sa ato ang sign convention man gud is kuan siya if kuan ta from negative to positive, kung makasugat ta og kuan na battery from negative to positive, so mo equate na siya kay ang to travel diri assumption to is I1 travels from positive terminal padong negative, so therefore ang total voltage ani niya is 1 ato i-subtract niya ni, so minus 25 is equals to 0. Okay, kay from negative to positive man siya, diba? Kung ato na i-extend nyo to ang loop nga to siya madto, so from negative to positive ang sign niya is negative, so manang we put here negative. However kung baliktad atong arrow is paana from positive to negative, so meaning kana siya kanang ang kana niya is plus po diri. Okay, mana ang sign convention for the batteries. So ato i-continue. So here ato na i-transpose ning C25, so we have here 10 10I1 then minus 10I2 plus 10I1 is equals to 25, then combining that would be 20I1 minus 10I2 plus 0I3 is equals to 25. So here for second loop na budda, so for the second loop so we have here starting with 5, i-take na to as positive ang direction ni I2, so we have 5 times I2, then i-take na to negative si I3 kay opposite man siya ni I2, that is minus 5 I3. What else? Si 10 ohm resistor na po naman siya sa loop 2, so i-take na to ang positive si I2 direction, so that would be plus 10 I2, and then i-take na to ang negative si I1 kay opposite man siya ni I2, that would be minus 10 I1 is equals to 0. So here rearranging, so combining I1, we have negative 10 I1, si I2 plus 15 I2, then minus 5 I3 is equals to 0. So this would be our equation 2. Next for the third loop, so for the third loop, so we have here third loop niya, so ni-interact si 5 with I3, so 5 ohm resistor times I3 plus, so plus gyapon sa convention ang mi-interact ni 20 ohm resistor si I3 gyapon, so plus 20 I3, and then plus gihapon for 5 ohm resistor na gyapon si I3, that is plus 5 I3. However for the 5 ohm resistor may interact po si I2 but in opposite direction, so mano minus 5 I2 equals 0. So combining, we don't have I1, so 0 I1. For I2 we have minus 5 I2. For I3 that is plus 30. I3 is equals 0. So here we now have 3 equations. So rewriting the 3 equations, we have 20 I1 minus 10i2 plus 0i3 is equal to 25. Next, we have negative 10i1 plus 15i2 minus 5i3 is equal to 0. Next, we have 0i1 minus 5i2 plus 30i3 is equal to 0. Now, solving this, so we have i1 is equal to 85 over 44. I2 is equal to 15 over 11. Then I3 is equals to 5 over 22. So, mga amperes ni sila. Okay. Now, to solve for the voltage across point A and B, that is just equal to the voltage on the 10 ohm resistor. So, solving for the voltage at the 10 ohm resistor, so balik ta itong ganitong gibuhat. A, that is voltage at the 10 ohm resistor, that is just equal to the current passing to that 10 ohm resistor multiplied by the resistance of that resistor, that is 10 ohm. Now, the current that pass there is the difference between I1 and I2, diba? Ni-interact man si I1 and si I2. So, that would be I1 minus I2 multiplied by the 10 ohm resistor. I1 is 85 over 44 minus I2 is 15 over 11 multiplied by 10. So, the answer is in volts. So, that would be equal to 5.682 approximately. So, approximately 5.682 volts. So, this is our answer for the voltage drop. So, ganiha sa ito kay taas ka ito siya. So, 5.682 lesser than siya sa 55 volts. Next, for letter B. So, for letter B, we're going to solve for the current at the 20 ohm resistor. So, kano siyang last kanina. And what is the current there? That is just equal to I3. And what is I3? So, this one is equals to I3, which is equal to 5 over 22 amperes. So, that is our answer. Okay. Now, please take note of the answer because in this problem pod class, we're going to solve this by using other method. Okay, by using the other method. So, ating erase. Then, nato apilon. Kanilang diri. Okay, using the other method aside from Maxwell. So, here, since medyo dili pa na siya complicated, actually, we can model this one into this. I can transform this one into this model. We have a battery. Then here, gibranch siya. So, I will write this in this way. So, gibranch siya. Then, after that, gibranch na po dire. Gibranch po sa last. But this one, series na siya. Then, gibalik og branch dire. Then, gibalik na po sa 1. After, naana dire ang usa. Before pa may balik na to sa before pa may balik sa battery. So, this is plus and minus. So, you notice, kaning naulhi kan si dire. This is the 10 ohm resistor. This is the 10 ohm. This is the 5. This is the other 5. And this is 20. Actually, in order to solve for the voltage here, first is we're going to solve for the total resistance, R total. So, here, this can be modeled further into, diba? We can combine this one, 5 and 20. So that it will be look like this. Mana siya. Mana. So, mausa na siya. Okay, so mausa. This one would be 25. This one would be 5. This one would be 10. Then napudira. This one would be 10. So mo na iya ikadawang transformation. Gi-combine ni ang iyahang resistance. The next, the third transformation would be combining the 5 and 25. So we're going to combine this. 5 and 25 are parallel to each other. So use the parallel method, or you can just simply combine these three because the three here are parallel to each other. So if we're going to combine this, so mahimo na siya og ingani ang circuit. Mahimo na siya ingani. This would be the 10 ohm resistor, and this is one is the combination of this 10, 5, and 25. So solving for the R total there, we're going to use 1 over R total equivalent, that is 1 over 10 plus 1 over 5 plus 1 over 25. So the answer here, RT is equals to, so that would be 1 over X, 1 over 10 plus, that would be 1 over 10 plus 1 over 5 plus 1 over 25, then 1 over answer, that is 50 over 17. So this one is 50 over 17 ohms. So therefore the equivalent here is 50 over 17 ohms. And since kinyong kita ang class A transformation, nahimo na siya og series. Duha na lang ka resistor. Since ato man siyang gipa-combine. If you know how to transform this one into this, mas simpler mo gani siya kitaon. So since na-convert na siya, so this is 25 volts. So diba atong gipangita is when you napansin, this is node B, this is node A. So therefore, what we have to find here is just the volt, this one, the volt here, AB. Okay, so in solving for the volts there, that is diba by series connection, that is for the volts we have 25 volts is just equal to the total voltage is equal to voltage at AB plus voltage sa 10 ohm resistor. So we need to find first, because this one VAB can be expressed as I. Okay, since sa may I diri kay this is series man, I times 50 over 17 plus the kanang the voltage at 10 here is I times 10 pod. But since we're after with VAB, so VAB ni siya mo man atong pangitaon. So VAB, since given ang total voltage, given na po nito siya, we only have the total current left. So in order to solve for the total current, we're going to use I total equals to V total over R total. What is the total resistance here? So yung sum up mean 50 over 17 plus 10. So total voltage is 25 over 50 over 17 plus 10. So the result is 25 over 50, 25 over 50 over 17 plus 10. So the answer is 85 over 44. That is the total current, 85 over 44 amps. So substituting that one here, transposing the other side, we have VAB is equal to 25 minus 85 over 44 times 10. So the result is 25 minus answer times 10. The result is 5.682. So the same sa tanong kaga niya. That is 5.682 volts. Okay. Medyo gamay na siya, but if kay bola ka mo transform ani, if you know how to transform this circuit, okay, this circuit into this one, now you can directly solve by transforming the circuit into an equivalent resistor. Okay, so let's proceed to capacitance. So capacitance, this is the ability of ikuan of a material to store charge. Okay, so ato ang capacitor actually kung imo na kanon i-dissect na or buna nimo ang capacitor actually mo ni forma. So this is ang yaha vessel, then na dry plate. So kana mga conductor plate na siya, then of course separated na sila. Okay, so separated na sila, wala sila gi-connect na conductor plate na. Okay, so separated na sila ha. Separated na. Separated by an insulator or known as dielectric. So dielectric. So kana siya mag-store ni siya charge. Mag-store ni siya charge, mura siya tangkis tubig. So nade, let's say this is positive terminal, then this one the negative terminal. Actually, there are some capacitors nga wala siya murabag kanang non-polarized nga wala siya wala siya gi-indicate nga positive terminal or negative terminal. So kana mga ceramic capacitors kana inganig porma kung kita man na mga ceramic capacitors na na designation din nga na. So example of ceramic capacitors wherein wala siya distinction sa iyang positive and negative kanang terminal. So here mo store niya siya charge, meaning diri we have of course a potential difference, EMF or voltage, and of course capacitance mara siya tubig, so therefore tangke sa tubig, so mosoda ang charge Q. Okay, so once mapuno na ni siya, so puno ang nig charge diri. Now if imo na siya i-release, tremendous amount of quantum energy iya pud i-release mo, nagigamit ni siya kanang sa motor, kanang CDI, kanang capacitor discharge ignition system. So gigamit ni pag start up sa katong kanang kuan sa pagdagan sa motor tungod kay daw kay sana energy nga iya i-release kaning capacitor. And napo ni siya sa mga mostly common ni siya sa mga electric motors. So kana electric motors inig jump start ana lisod man kung gamay lang ang kuryente, so it needs a capacitor. So mara ni siya pansamantalang storage sa atong charge. So mani iya gamit, and then its formula for capacitance, it is somewhat related. Okay, ang capacitance, there is a relationship between the charge and the voltage. Okay, di ba? If higher the voltage, daghang kay masud nga charge. Marabag sa tubig ba, kung taas ang pressure, daghang pagkag amount of water nga imong mabutang. So here, the proportionality constant between them is what is known as CV. So this is the capacitance. So kaning C dire mo na siya ang ato ang capacitance. And then unit analysis, so charge is in coulomb, and then voltage is in volt. So atong capacitance di is in coulomb per volt, or giterm na niya as farad. So 1 farad is 1 coulomb per volt. So muna siyang farad abbreviated as F. So daghan nagklase, but most of our capacitors naranas mga nano micro, pero naay mabutog farad, kusog na kay na siya. So mostly nanofarad, microfarad nga na. So here mo gina general formula for our capacitor. So saya girelate niya ang charge, ang capacitance, o ang voltage. Now let's go to the power that will be emitted here for our capacitor. So ang power kaya niya ma-release. So power that is just equal to P. This is in watts. That is equal to 1/2 CV squared. Okay, so mara na siya. And if you're going to express this in terms of Q and instead of V, that would be equal to 1/2. Then mahimo na siya og kanang Q squared all over C. Yan na. So giderive na po na siya. So again, ang governing principle for capacitance is the charge directly proportional to voltage, and the proportionality constant is the capacitance. So ang capacitance kung ano siya, para siya ang measurement for every material or for every capacitor. So nagkalain-lain na sila capacitance. So mara nito ang gamiton, power and the relation between the voltage and the capacitance. So for the capacitor in capacitors in a circuit, so the same siya with resistor, naputay nakakabit nga capacitor in series and in parallel. Okay, so for series connection, so we have here, let's say this power source, then naka-series ang capacitor. Say this is C1, C2, C3, and here current flows. There's a current, diba? The charge is associated with current. The one that current is equals to charge Q all over time. So meaning they are somewhat related. If we have a current flow here, of course we also have a charge that is flowing here. So if the current in a series circuit is the same throughout, so we also say that Q here is equal also. Meaning, for a series connection, the total charge is equal to the charge nga miagi sa 1 equal po sa charge miagi sa 2 equal po sa charge miagi sa 3. Okay, mana siya. And then, for the total voltage, okay, total voltage, V total, again, that is just the individual, that is just the sum of the individual voltage. That would be V1 plus V2 plus V3. But according to the equation for capacitor, diba, we all know that capacitor, that is Q is equals to CV. So therefore the voltage is equals to Q over C. So ato na siya i-substitute area. So V1, that would be Q1 all over capacitor 1 plus Q2 over C2 plus Q3 over C3, and the V total is just equal to the total charge all over, of course, the total capacitance. So here, since Q1, Q2, Q3 is just equal to Q total, so a factor out na din siya. So therefore we have Q total over C total is equal to Q total 1 over C1 plus 1 over C2 plus 1 over C3. So therefore ma-cancel na siya. So we now have for series, okay, C total is equals to 1 over C1 plus 1 over C2 plus 1 over C3. So as you notice, class, a capacitor that is arranged in series, mura siyag resistor nga naka-arrange og parallel, diba? Inverse. So mura na tong bantayan for capacitor. That is for capacitor in series. Now let's jump to the capacitor in parallel. in parallel connection. So let's say we have here a power source, usa ka capacitor, then duha, then katulo, so on and so forth. So C1, C2, C3, and we have total voltage here, or the voltage source. So again, since this is since this is in parallel connection, so naka-parallel man ta, automatic, I1 or I total is just equal to I1 plus I2 plus I3, or gisum up. In terms of charge, that is Q total is equal to Q1 plus Q2 plus Q3. And of course, the voltage here is V total is just the same. V1 equal to V2 equal to V3. So here we're going to base our derivation from the charge. Okay, so from the charge, we have the charge going back here or here. Q is just capacitance times the voltage. That would be C total times the V total is equals to, for Q1, that is C1 V1 plus Q2 C2 V2 plus Q3 C3 V3. However, for parallel connection, V1 is just equal to V2 equal to V3 equal to V total. Then we can factor out the niya. Okay, so ato siya factor out. We now have V total C1 plus C2 plus C3. Now we can cancel out this one, cancel the ni. So therefore, the total capacitance of a parallel connection is just the sum of the capacitance for each individual capacitor. Mayon duman class, actually baligi na silang duha for resistor and capacitor. Mara gid na inyo i-take note. So we're going to have some example here. So here, problem number 1, determine the capacitance of the single capacitor that is equivalent to the parallel combination of capacitors shown in figure 16.9. Then find the charge on the 12 microfarad capacitor and the total charge contained in the configuration. Okay, so here unang gipangita, so required determine the capacitance of a single capacitor that is equivalent to the parallel combination. But patabot ana, that is the total capacitance. Kaduha, the charge on the 12.0 microfarad, that is Q at 12 microfarad nga capacitor. Katulo, the total charge obtained in the configuration, that is Q total. Ikaupat, derive a symbolic expression for the fraction of the total charge contained on one of the capacitors. So kamo na lang bahala na. Let's have A, B, and C na lang. Anyway, follow-up questions na po na siya. So solution. Since this is parallel, again for parallel, opposite C has a resistor. For parallel, the total capacitance is just the sum. C1 plus C2 plus C3 as plus C4. So namtay upat. The first is 24 microfarad. Remember, naka-micro na tanan, dapat consistent ka. If naka-micro tanan, din walay problema. If naiusa nga nasokwahi, so that is the time nga imo sa na-convert ang usa para ma-uniform. Okay, so simplifying this, we have 24 plus 12 plus 6 plus 3. This is all in all 45 microfarads. 45 microfarads. That is the total capacitance. For letter B, the charge daw at 12. Okay, at 12 microfarad. So Q at 12 microfarad. So we all know that Q is equals to CV. That is the Q at 12 microfarad is equals to the capacitor there and the voltage. So since this is parallel, the voltage on every capacitor is just the same with the source, that is 18 volts. So therefore that would be 12 microfarad multiplied by 18 volts. Since naka micro pa na, so we're going to multiply that one. Kaya ang 1 farad, okay, 1 farad is equal to kung ang micro, 10 to the power negative 6. 1 over 1 million. Okay. Ang usa ka farad is equal to 1 million microfarad. Cancel ni, so farad na lang yun. And farad times volt is coulomb. So that would be 12 times 18 times 10 to the power negative 6. The answer here is 2.16 times 10 to the negative 4. Okay. So that is 2.16 times 10 to the power negative 4 coulomb. So muna ang charge. Then for letter C, the total charge here. So Q total. So since we already know C total and then the source voltage, then we can say that the Q total is just equal to C total times the voltage source. So C total is 45 microfarad times 18 volts, and convert microfarad into farad. That is 1 million microfarad is 1 farad. So this will now become, so may mo nag 8.1 times 10 to the power of negative 4 coulomb. So mana siya ay total charge nga na-generate aning upat ka capacitor. So nga na siya class pag answer. So we have here next problem, capacitor connected in kanang in series. So automatic mabaliktad ani. So ang required ani nga problem is for letter A, the equivalent capacitance, so that is C total. So muna siya ang required. Then for B, we have compute the charge on the 12 microfarad. So Q at 12 microfarad ng capacitor. Then C, find the voltage drop across the 12 microfarad. So the voltage at 12 microfarad. So solution. So for series, that is 1 over C total is equals to 1 over 3 microfarad plus 1 over 6 microfarad plus 1 over 12 microfarad plus 1 over 24 microfarad. So the total capacitance here is the reciprocal of the answer of this one. 1/3 plus 1/6 plus 1 over 12 plus 1 over 24. The answer is 8 over 5. The total capacitance here is 8 over 5 microfarad, or there's 1.6. There's 1.6 microfarad. So, muna siya ang total niya capacitance. Now, we're going to solve for the charge. So, that is letter B. That is the charge at 12 microfarad. Actually, for a series, ang charge at any of this capacitor is just the same. Okay, naka-series man, so therefore, ato pangitawon ang total charge niya. Okay, the total charge is just equal to the individual charges for each capacitor. So we have here Q total is just equal to Q 12 microfarad is equal to the total capacitance and then the voltage source, that is 18 volts. So we now have 1.6 microfarad times 18 volts. Convert microfarad into farad, so 1 farad is 1 million microfarad. So we have here the total charge, 1.6 times 18 times 10 to the power negative 6. The answer is 2.88. 2.88 times 10 to the power of negative 5 coulomb. So mana iha total charge. That is also equal to the charge at 12 microfarad or any other capacitors here. Then the voltage drop. So for the voltage drop across 12 microfarad, that is just equal to the balik ta sa capacitance nga equation, that is Q equals CV. So therefore V is just equal to Q over C. That is Q at 12 microfarad all over the capacitance there is 12 microfarad. So here Q of 12 microfarad is equal to the total Q. Okay, the total Q is 2.88 times 10 to the power of 5. So we have here 2.88 times 10 to the power of negative 5 coulomb all over 12 microfarad. Then imo siya ikuan 1 farad is 1 million microfarad. So makancel na siya. So we now have answer divided by 12 times 10 to the power of negative 6. So the answer is 12 over 5 or 2.4. So the voltage there is 2.4 volts. So mana siya class. So let's proceed to the next one. So here we have a combination of the capacitors either both in series and parallel. So here ato sana sila simplify, rearrange. So ako i-draw ha. So this is the first capacitor here, 8 microfarad. Then next is may branch siya. So we have here 6 and 2. May balik na po. Then lastly kan siya 8 microfarad hanggang nag-return siya sa power source. Plus or minus, this is 9 volts. Here we can transform this. Let's say we're going to combine this class. Since they are parallel to each other, then ato siya i-combine into a single unit na lang. So that it will now become, hindi mo na siya ganyan nani. Okay, so this one is our 8 microfarad. This one, since both of them are parallel, so diba for parallel connection, the capacitance, just add the two capacitance. So 6 plus 2 is 8. This would be 8 microfarad. This one is 8 microfarad. So we have 3 8 microfarads arranged in series. So since ang ipangita diri is the equivalent capacitance, so the first required A is the C total or the equivalent capacitance, then the charge on each capacitor. So ikaduha Q of each capacitor. C the potential difference across each resistor. C is the voltage for each. So let's solve. In pinaka-important diri is the total capacitance. So A C total, that is 1 over C total is equals to 1 over 8 plus 1 over 8 plus 1 over 8. And the answer here is, so that is 3 over 8, 8 over 3. That is 8 over 3. 8 over 3 microfarad. Okay, so wala siya. And kabaralay solve for class 4. The charge. Okay, anyways, for the charge there, you just solve the voltage po dire. So voltage in series kay ba naman mo equal na dire ang Q. Okay, ang Q dire, mulabay dire ang Q. So labay dire ang Q, labay dire ang Q, labay dire ang Q. So ito lang ko anon sulbon. So for letter B, Q at 8 microfarad. So that is equal to 8 microfarad multiplied by the voltage drop there, but we don't have the voltage drop there. So maglisod ta, but we know that the Q at 8 microfarad is just equal to Q total ba? When Q total is equal to C total, then the voltage source, that is 9 volts. So that would be 8 over 3 microfarad times 9 volts and multiplied by 1 farad over 1 million microfarad. So that would be 8 over 3 times 9 times 10 to the power negative 6. So the answer would be 2.4. This one is 2.4 times 10 to the power negative 5 coulomb. And of course, equal na siya sa Q pod at 8 microfarad. But however, on the second one, the Q at 6 microfarad and 12 are different. Okay, lahi na sila. And the voltage there, in order to solve for the voltage para to makita ang iyahang Q dira, so the voltage there is just equal to voltage there is the voltage at 6 and 2 nga capacitor. There is the voltage between 6 and 2 nga capacitor, that is equal to Q total all over the total capacitance there. So diba ang total nga capacitance dira, okay, ang total ano nga capacitance is 8 microfarad. So 8 microfarad, so that would be Q total is 2.4 times 10 to the power negative 5 coulomb. Okay, so equal man ang total voltage. So diri so this would now become all over, so may diri og 8 microfarad times 1 microfarad is 1 million farad, 1 million microfarad. So here we now have voltage on 6 and 2, so mahimo na siya diri og 2.4 times 10 to the power of negative 5 divided by 8 times 10 to the power of 6 to the power of negative 6. So the answer would be 3. So the voltage on 6 and 2 is 3 volts. So therefore ang Q po dira, so Q at 6 microfarad is just equal to the voltage there, or the capacitance is 6 microfarad times 1 farad is 1 million microfarad multiplied by the voltage, that is 3 volts. So therefore that would be 18 times 10 to the power of negative 6. So we have here 1.8 times 10 to the negative 5, so 1.8 times 10 to the power of negative 5 coulomb. And for Q at 2 microfarad, that is just equal to 2 microfarad multiplied 1 farad over 1 million microfarad multiplied by same gihapon 3 volts gihapon siya because they are parallel to each other, 3 volts. Therefore this one is equal to 2 times 3 6. Okay, so this would be equal to 6 times 10 times 10 to the power of negative 6 coulomb. So yun na class, the rest kamo lang po i-analyze. Okay, so mana siya, and then let's proceed to the next one. So this is all about energy of a capacitor. So a fully charged defibrillator contains 1.2 kilojoules of energy stored in a 1.10 times 10 to the power of negative 4 farad capacitor. In discharge through a patient, 6 times 10 to the power of 2 joules of electrical energy is delivered in 2.5 milliseconds. A. Find the voltage needed to store 1.2 kilojoules in the unit, and then what average power is delivered to the patient. So here required the voltage needed to store, that is V, to store 1.20 kilojoules of energy. Okay, ikaduha, that is the average power, P average. So solution, actually sa iyahang kuan class figure niya, sa iyang figure, so mo ni ang defibrillator, of course connected gina siya sa kuan, nanay kuan capacitor. So kanang capacitor nag-store siya energy. Okay, nana siya daan energy, that is 1.20 kilojoules. Okay, nana siya, and then mo na siya iyang na charge. So ang kanisiya, the energy sa solution for letter A, the energy of capacitor is energy is equal to 1 half, di ba? 1 half CV squared. So since ipita CV, so that would be 2E is equals to CV squared divided by C, taking the square root, so we have V is equal to the square root of 2EC. The energy here should be in joules, and the capacitance here should be in farad, so that would be square root para ma-volts pa siya. 2 times the energy is 1.2 times 1000, kay 1000 joules is 1 kilojoule. Then divide by capacitance here is naka-farad na, so that will be 1.10 times 10 to the power negative 4 farad. So we're now ready to solve for its voltage. So that would be square root of 2 times 1.2 times 1000 divided by 1.1 times 10 to the power of negative 4. So the answer here is 4670.99 volts. As you notice, very large amount of energy yan release. So diba, very large yun. And for letter B, the average power. So actually the average power is in watts man. So since ang na-deliver daw sa patient is 6 times 10 to the power of 2 joules, so we have here 6 times 10 to the power of 2 joules divided by in time, the time is 2.5 milliseconds, so that is 2.5 milliseconds, and 1000 millisecond is 1 second. Para joule per second, that is in watts. That would be 6 times 10 squared divided by 2.5 times 1 over 1000. That would be 240,000 watts. So 240,000 watts, or in kilowatts, that is 240. Okay, so this is 240 kilowatts. So mana siya class. That is our answer. Okay class, let's continue for the last topic for lesson 1. So we are now on the measuring instruments. So the most, or one of the popular measuring instrument nga naa sa kuan, mga magamit sa kanang electrical nga side is ang kanilang gitawag nga kuan, galvanometer. So kaning galvanometer, and the galvanometer measures the current and also the voltage of the circuit. So how are they going to measure this one? Suppose if the galvanometer, so una na to is the galvanometer is measuring the current. So unsa may inner workings ana sa sulod, actually ang porma sa galvanometer, so para siya for an analog, so na siya ana ay window niya na needle, so mo deflect na siya dira kung asa siya mo timing kung unsa pod nga values sa iyang voltage o sa iyang current. So inside the galvanometer, if we're going to measure the current, so let's say this is coming from the circuit. So assuming coming from the circuit niya, so here pass through siya inside our galvanometer, and of course our galvanometer also offers some resistance, and we're going to term this as Rg, the resistance of our galvanometer. Then balik na po siya ngadto, connected na po siya sa ato ang circuit. So i-connect mo ni ang galvanometer sa circuit, and in measuring current, the galvanometer should be connected in series. This should be in series. So in series with the circuit to be measured. So mawagi na siya sa galvanometer. And here for our kanang galvanometer, so para mo dili maguba ato ang instrument, so nagitawag nga gikonektahan siya og shunt resistor. So kan siya shunt resistor, and we're going to denote this one as RS. So again, this is a shunt resistor. So ang gamit ani is if ever na madaot, so i-bypass niya ang ubang current diri so mo bypass diri ang current maagi sa shunt, then mabalik na po nito. So therefore, if we have an input current here, that is the current coming from the circuit, we're going to label this one as IC. Then ang current nga mo pass through sa galvanometer is our IG. Then the current that will pass through the shunt is IS. So by Kirchhoff's law sa node starting with the current, so that is IC, the current coming from the circuit, is equal to the current that will go to the galvanometer plus the current that will go to the shunt resistor. And from the voltage law, so voltage, so that is the voltage on the galvanometer is just equal to the voltage of the shunt, and we all know that the voltage of the galvanometer is just equal to IG times RG, which is at the shunt, that is IS, multiplied by the shunt resistor RS. But normally dili na kay ihatag ang IS, since ang important naman dili kay ang IG and IC. So solving for IS in terms of IG and IC, that would be IS is equals to IC minus IG. Okay, so substituting, this is IG, then RG is equal to IC minus IG, then RS. Okay, so more class ang importante nato ang kanang kitaon. And then for the voltage, in measuring the voltage, it should be kanang parallel to the circuit. Or to the device nga imong i-measure. So ang setup ani niya for the voltage, so this is from the circuit, naka-parallel na siya. So na itong GRA, galvanometer, with some resistance, internal resistance, then i-connect na po nimo ang shunt in series. This is our shunt resistor kung musukod ta og voltage. So here if we have a source voltage here from the coming from the circuit, okay, let's say this is VCC. So we have here VCC, since this is kuan naka-series man ni ang galvanometer ug ang resistor. That is, the source voltage is just equal to the voltage in the galvanometer plus the voltage in the shunt resistor. Okay, so if naay current nga mo pass through na, I'm going to label this one as I, the current from the circuit. So this would now become VCC is equals to IC, then RG plus ICRS. Okay, then factor out IC, so we have IC, then RG plus RS. So mo na siya ang governing ng mga equations in order to solve. Maybe either you want to know the internal resistance of the galvanometer or the amount of resistance needed for the shunt resistor. So lahi sila orientation sa placement sa shunt. Kung mag-measure kag current, naka-parallel siya sa galvanometer. Kung mag-measure kag voltage, ang shunt kay naka-series. Okay, let's solve some examples. So here it states that a galvanometer has a resistance of 5 ohms and full scale deflection is produced by 15 milliamps. Calculate what resistance must be used to enable it to read 1.5 ampere and 1.5 volts. So the first reading, so ito nakitawan ha. Kung inyo kanang ma-notice, so ang pinakauna is nag-measure siya og current. Okay, nag-measure siya og kanang kanang current diri so here ang orientation ani is, since nag-measure man siya current, so ay orientation would look like this. So from the circuit, gi-bypass siya sa shunt, then na diri galvanometer, then balik na pud. So here ang galvanometer, that is RJ has a resistance of 5 ohms, and then ang kaning deflection nga na-produce niya by 15 milliamps, actually mo na siya ang current nga may pass through the galvanometer. Kay of course mo man di ba sa inside the galvanometer naman to scale dito nga mo deflect, so mo na siya ang iyang na read, that is IG. So IG is equals to 15 milliamps. So ang equivalent sa milliamp is 1 amp is 1000 milliamps na class. Next, when we say ma-read niya ang 1.5 ampere, actually kanang 1.5 ampere, that is the current coming from the circuit. Okay, so that is IC is equals to 1.5 amperes. What we need to find here is RS, that is the resistance kailangan para sa atong shunt. So kani siya RS. Na calculate what resistance must be used to enable it to read 1.5 ampere. So solving for RS, follow lang ta to. Katong pag-solve na to ani, that is the the voltage on IG is just equal to the voltage on our shunt. That is VG is equals to VS, and we'll know VG is just equal to IG, then RG. The voltage in the shunt is IS, then RS. But IS, that is just the difference of the current that is from the circuit minus the current nga misud sa galvanometer. So that would be IC minus IG RS, then IG RG. So here dividing both sides by IC minus IG minus IG. So therefore our RS is equal to IG RG all over IC minus IG. So plugging the values, the IG here is 15 milliamps. So 15 milliamps, ato i-change into ampere. That is 1000 milliamps. 1 ampere. RG here is 5 ohms. So 5 ohms ni siya. Divide by IC is 1.5 amps minus 15 times 1 over 1000 para magiging amps na siya. So therefore the unit here for RS is ohms. So we have 15 times 1 over 1000 times 5 divided by 1.5 minus 15 times 1 over 1000. So the answer here is 5 over 99. The shunt resistor should be 5 over 99 or 0.051 ohms. So mana siya ang shunt resistor nga needed para makaread siya ang value. Okay. Ikaduha, what if the kono? In that case, makaread siya og voltage na pod. Okay, voltage reading na pod. Kung saan po ikinahanglan nga resistor. So for voltage, ang arrangement niya is from the circuit, then galvanometer, and then resistor, the shunt. Okay, so we have here RJ, then this is RS. Again, the current flowing here from the circuit is sa naman kaninang 15 milliamps na. So di na siya 1.5 ampere kay kanman mo naman ay scale deflection. So whatever the scale deflection here, okay, whatever the scale deflection inside the galvanometer, mo na po siya current coming from the circuit. So that would be IG. So ang IG mo po na hingagi sa atong shunt kay series naman sila. So therefore we can say that since ang ma-read man niya, no, so ang ma-read niya meaning that is the voltage coming from the circuit. So that would be the VCC, that is 1.5 volts. So mamanagikan sa ato ang circuit, that is 1.5 volts. So here, since this is series connection, so the VCC here, VCC is just equal to the voltage on the galvanometer plus the voltage on the shunt. So here, the voltage in the galvanometer is expressed as IG, then RG plus IG RS. Ato ikuan factor out si IG, so RG plus RS na lang. This is VCC, the source voltage from the circuit. Divide na to si IG para solving for RS man ta. So we now have RG plus RS is equal to VCC all over IG. Transposing RG on the other side, so we have RS equals to VCC over IG minus RG. So here, substituting the data, so VCC is 1.5 volts, IG is 15 milliamps, so divide na po by 1000 para mahimong amps, minus RG here is 5 ohms. So therefore the shunt resistor should be 1.5 divided by 15 times 1 over 1000 minus 5. So the answer here is 95. So dapat di ay para makaread ka og 1.5 volts, dapat 95 ohms ang imong i-connect in series with the galvanometer. So mao na siya class. Then let's proceed to the last problem. So here it states that the resistance of a galvanometer is 100 ohms and it can withstand a maximum current of 100 milliamps. So mapod ko na current nga pwede ra masud sa galvanometer. How this can be converted into an ammeter to read 10 milliamps, or I mean 10 amps. So again, this problem is used to measure current. So if it used to measure current, then ato siya atagan kung unsa iyahang shunt resistor nga kailangan. Okay, the diagram would look like this. So para di siya daot, ato siya tagag shunt resistor. So mana siya. Okay. So ingon siya para makabasa daw siya og 10 amps na kuan. So meaning kanang 10 amps, that is not the current inside the galvanometer, because it was already stated nga ang makayra ni galvanometer is ang 10 milliamps. Mao nang natay shunt para dito mo divert ang uban. So kanang 10 amps mao na siya ang kanang kuan current from the circuit. This one 10 amps. Then napunta diri IS, then IG. So the IG here is equal to 100 milliamps. So siya, and of course we have RG. So our RG, the galvanometer resistance is 100 ohms. And we're going to solve for, as always, RS. Okay, so since the connection of the galvanometer and the shunt resistor is kanang kuan mo siya nakaparallel, so therefore we can say that the voltage across the galvanometer is equal to the voltage across the shunt. The voltage in the galvanometer is just equal to current IG and RG, while at the shunt that is IS, RS. But IS is just the difference between the circuit current minus the galvanometer current times RS. So since after rata ni RS, so we are going to divide both sides by this one, IC minus IG. So divide IC minus IG, cancel ni, so therefore we have RS is equals to IG RG all over IC minus IG. So here ato ang IG class mo siya maximum nga makayara ni galvanometer, so that is 100 milliamps. So 100 milliamps, so we all know 1 amp is 1000 milliamps multiplied by RG, that is 100 ohms, dividing by IC, that is 10 amps, minus 100 milliamps. 1 amp is equal to 1000 milliamp. Okay, so the resulting unit would be in ohms. Simplifying, we have 100 all over 1000 times 100 over 10 minus 100 over 1000. So the answer would be 1.01. That is 1.01 ohms. So mana iyang kailangan sa galvanometer in order to read 10 amps from the circuit. Okay, so I hope class inyo na sabtan, and if you have further kanang questions, so please don't hesitate to PM me. So thank you for listening and study very well, and thank you.